This series of videos will be about Section 5.4 in college algebra in context, exponential and logarithmic models. This table shows the number of cohabitating without marriage households in thousands and selected years from 1960 to 2008. Let's see what they want us to do with it. First, graph the data in a table with x equaling 0 in 1960. Find the exponential function y equals f of x that models the data with x equals 0 in 1960. Graph the model function on the same graph as the data and estimate the number of cohabiting households in 2014 using the model. So first we need to graph the data on the table, and as you're saving the data, make sure you make no mistakes in data entry. Even one digit wrong will make the wrong equation. 10, 20. For the window, I've chosen 0 to 50 and 0 to 6,500. Here we have the data, and we know we used from 0 to 50 for the x values, and from 0 to 6,500 for the y values. Stat, want to calc, and we'll go down to an exponential function, and that is here at 0. So we're going to enter that. We will want to save it. So y-vars and save it as a function. Now we can calculate it. Okay, so y equals 4.08704. This will be 705 times 1.064 to the x power. We know that the equation is y equals 408 and 705 thousandths times 1 plus 0 and 64 hundredths to the x. And we found that, once you've entered the data, we found the exponential function by going to stat, then calc, and selecting 0, which is the exponential regression. Now we need to graph that model on the same graph. Let's look and see what happens. Here it is. Remember, we're 0 to 50 and 0 to 6,500. I'm modeling the function of the same graph. And the last thing is to estimate the number of cohabiting households in 2014 using the model. There are two different ways we can go about that. We could take the equation y equals 408 and 705 thousandths times 1 and 64 thousandths raised to the 54, and when I use that, I find out we get 11,648 thousandths. If you use the graph on the calculator, use the graph, and y2 find the value when x equals 54, you will get 11,835 thousandths of cohabitating households. So we get a little difference because this is the rounded model and this is the actual value from the equation. And here's where we got that answer from the intersection. Now, constant percent changes. If the percent change of the outputs in a set of data is constant for equally spaced inputs, an exponential function may be the perfect fit for the data. If the percent change is approximately constant for equally spaced equally spaced inputs, an exponential function may be an approximate fit for the data. And let's see how that actually happens. Here we have a set of data with the input x and the output f of x. Test the percent change of the outputs to find if the function is exactly exponential, approximately exponential, or not exponential. And here's how we do that. First, we go to the difference. The difference between 4 and 16 is 1 up 12. From 16 to 64, it went up 48. From 64 to 256, it went up 192. From 256 to 1024, it went up 768. And from 1024 to 4096, it went up 3072. These are equally spaced inputs. Now to find the percent change, you take the change and divide it by the original number. So the change was 12, divide it by 4, and as a percent, that's 300%. Here we take 48 divided by 16, and as a percent, it's again 300%. 192 divided by 64. The change divided by the start number is again 300%. The change, 768 divided by the 256 that it was first, is again 300%. And 3072 divided by 768 is again 300%. So this will be, because they are the same, this will be exactly exponential. Exponential model. If the set of data with initial value A, and constant rate of change R, written as a decimal, for equally spaced inputs x, the data can be modeled by this exponential function. This is exponential growth. Notice this is plus, so it's growth. And by the exponential function y equals a times 1 minus the rate of change raised to the x for exponential decay. So growth is with the plus, decay is with the minus. When you are using technology to fit the exponential model to the data, you should align the inputs to reasonably small values. You don't want your inputs being too large, or it will grow very, very fast.